Okay. If you see this word, derive or derivative, so this is a new phrase. If you ever see that phrase, this is what you do. F prime of x, which is the derivative of the function, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So what we're going to do now is we are going to do something very similar to what we've done before, except instead of putting a in there or an actual value for a, say 2 or 3 or 4, we're going to find the derivative as a function. And then I'm going to help you try to kind of figure out whether or not you did that correctly. Okay? So let's look at this example. F of x equals square root of 2 minus x, and then we have b, f of x is x over x minus 3. The group last year definitely were able to do these type of problems. But if we extend it a little bit further, they found it too difficult. So I'm going to add one more example. I don't know. We might have time for it today. It's going to take a while to get through. But the algebra, you guys need practice with. Trust me. So we give it a shot. F prime of x is equal to, I want to find the derivative of the square root of 2 minus x. That's what I want to find. Okay? And so what I do is I take the limit as h approaches 0 of what? X minus h, because you have to distribute the negative, minus square root of 2 minus x all over h. So in order to, the whole idea is I want to use my limit. I want to use that h approaches 0. I can't yet because it becomes 0 in the denominator, and that creates a problem. I have to get rid of that h. In order to do so, I have to free up the h in the numerator. So how can I get rid of those radicals? Multiply by the conjugate. If you see a square root, most of the time you're going to have to multiply by the conjugate. What is the conjugate? Okay, just to refresh your algebraic memories, why can I just multiply by that? Because it's equal to 1. Something over itself is equal to 1. So I'm just multiplying by 1. That creates no problem. Why do I multiply by the conjugate? Because the middles go away. Yes, very good, Ina. All right, so we go here. I now have the limit as h approaches 0 of, what do you get in the top? Two minus x minus h minus parentheses 2 minus x. All right, yep, so 2 plus x divided by h times Is everybody okay so far with that? Do you see how I got the top? The bottom is just like it was. Okay, there's no difference in the bottom. So now what's going to cancel out in the top? The 2 minus the 2 and the negative x will cancel with this will be a positive x. I'm left with a negative h in the numerator. Okay, what happens to the h's? I'm left with the limit as h goes to 0 of negative 1 over the square root of 2 minus x minus h plus the square root of 2 minus x. But that's problematic, isn't it? I mean, I still have an h in the denominator. I can't plug in 0, can I? Why can I plug in 0? Very good. Even if I plug in a 0 in the denominator here, the entire denominator does not give me 0 as a result. As a matter of fact, you end up with, and this is the part that some people struggle with, so watch this. It's not very difficult, but some people miss this. I have negative 1 over the square root of 2 minus x, right? When you plug in 0. Plus the square root of 2 minus x. That happens a lot when you're doing a square root. So what do you get, Ben? So f prime of x, so the derivative is equal to negative 1 over square root of 2 minus x. Very good. Now, I'm sorry. Yep. Sorry. 2 of them. Sorry. Yep, 2 of them. I was jumping ahead to what I want to show you in your calculator. What? Okay. Any questions with that? Lucas, you have a question? Okay, I'm going to show you how you could check your answer. There's a variety of ways to do it. I want to show you this one. Take out your calculator. Okay. I want you to type in, our first one will be the function, our second one will be the derivative. If you're not very good with your parentheses, then type it in exactly like I have it. If your calculator doesn't show something that mine shows, don't worry about it. Just follow mine. We'll take care of your calculator issues at a later time. Okay, so you've learned how to graph these now, right? So I'm going to make the first one. I'm going to go up and make that bold so I know which is which. It looks stupid. Let's graph it. Okay, so let's think about it, folks. First of all, let's just try to make sense of this first. As you look at this the bold one, okay, so the original function, is the function defined for values greater than 2? Is the derivative defined for values greater than 2? So we're good there. I'm going to make a statement, you guys finish it off. The slope of the original function is always negative. Look at the derivative. It's always below the x-axis. So it looks like it matches here, but watch something I'm going to show you. Let's look at our second function, okay? So let's calculate a value Let's calculate a value. Let's see what the derivative is at 7. Okay? Look, or actually 7 wouldn't work. Let's choose a negative 3. as you can see, it tells you what the derivative is, or I'm sorry, what if you plug in -3, what you get for that one. Is that the derivative? This guy's the derivative, right? So it looks like f prime of -3 is equal to -0.22. So I'm going to write that down. F prime of -3 is equal to -0.22. Well, if I've done all my work correctly, I should be able to find the slope of that function and show that's -0.22 right there, right? That the value of the derivative should be the same as the slope there. And I'm going to show you how to do that. Second, calculate. Do you see one up there that we want to choose? dy over dx, that's number 6. That will calculate the slope for you of a function at any given point. And what do we want to do it at? -3. So I type in -3, and I want to be on the first one. It finds it. dy over dx is -0.22. It's the same. So that's one way you can check your work. Again, I go second, calculate. I select number 6, and I choose an x value of -3. And that's what differential calculus continues to be. Yes. Yes. So if you guys ever have a problem where it says, what is the instantaneous rate of change? What's the slope at a given point? You can always plug it into your calculator and do number 6, dy over dx. But with that said, you guys always have to justify your work algebraically. All right, let's try one more. I don't think we'll have time for the last one. We'll just do this one. Are you guys gone tomorrow? No. Okay, that's just juniors. Well, did you guys not get notes? You guys. F prime of x is -1 over 2 square roots of 2 minus x. Hey, we give it another shot. F of x is x over x minus 3. We need to find the derivative. F prime of x. Very good. Of over minus Okay, very good. Now you guys understand why we first were discussing complex fractions. This is what we want to be able to do here. In order to get rid of this h, I need to free up the h's in the numerator. To do that, I need to combine them into one fraction, because then I'll multiply by the reciprocal. So in order to combine these as one fraction, what do I have to find? Common denominators, what do I multiply this side by? X plus h minus 3 over x plus h minus 3. And how about the other side? Common mistake is that people would simply multiply this side by, say, h, or they would try to add an h to both sides. That does not work. You must multiply the top and the bottom just like we did. Okay, let's see what we get. Where's the limit as h approaches 0 of? What do you get right here? Very good job, Greta. Now what? Minus x squared. minus xh plus 3x all over what? No. All over h over 1. Okay, beautiful. Complex fractions. That's why we do them in algebra. What cancels? Yeah, again, you guys, this is so important. I want you to see this. As you notice, you see these front pieces, the x squareds cancel right away. You also see the minus 3x's and plus 3x cancel. xh minus xh, you're left with the negative 3h. When you multiply by the reciprocal, you're going to end up with h in the denominator, correct? And then, when you get that h in the denominator, that h will cancel. I multiply by the reciprocal 1 over h. I left my phone on, sorry. I multiply by 1 over h. Is that, you good? Derek? Multiplied by the reciprocal. Okay, let's finish it off. We have the limit as h approaches 0 of, what do we have in the numerator? Negative 3 over. Can we now plug in 0? Yes, we can plug in 0, and we get negative 3 over x minus 3 times x minus 3. How should we write that? So, to answer Ina's question from earlier, what do we write as our final answer? The final answer is f prime of x. The derivative of that function is equal to that. And if you want to check your answer, again, you could graph them both, check the value of the derivative at one spot, and then take your original function and find the slope at one spot, and those should be the same. And then you'll be good to go. You're ready to practice this? You guys, we have, let's see, next Thursday is the end of the semester, right? Or end of the quarter. We are going to test before then. We only have, we'll be done with 3.2 here. We only have 3.3 to work through. Trust me, you guys will be good to go. We won't have a problem getting a test in. I'm going to pause this. I'm going to get your assignment. Okay, here's your assignment. Section 3.2. Page 142, numbers 1 through 4, 14, 15, 19 through 27, odd, and 35 through 36. It is super important that you guys start this right away. I'm gonna tell you that in order to get your test in by Thursday, I'd like to have an extra probably 1 day in there, which we're not going to get. So, and that's fine. But I'm just saying that the more on top of things you are in terms of getting your homework done, you should really look at these problems immediately tonight. So try to spend some time. If you have questions, I'm around after school today. I'm around after school tomorrow, but tomorrow morning we do have teacher meetings. So. You can sit in 8th hour so long as you don't sit next to a certain person and bother their learning. All right.